Hello, and welcome to Exploring Axon, a podcast where we discuss Axon Framework, Axon Server, and their ecosystem. I am your host and a software developer at Axonic, Sarah Torrey. In this episode, I spoke with Simon Zambrovski and Jan Galinski of the Hamburg-based consulting firm Holisticon. We discussed the Avro Axon Serializer that they have been working on for the past year. They talked about the advantages of using this serializer over Xtreme or Jackson serializers. This was a very informative and interesting conversation, and I hope you enjoy it. Let's have a listen. Hi, Simon. Hi, Jan. How are you both today? We used to be neighbors, but now we're kind of thousands of miles away. So anyways, how are you? And where are you? Jan, if you'd like to start.
Yeah, sure, love to. My name is Jan Galinski. I'm an IT consultant / developer / architect, whatever. And I work for Holisticon, IT consultancy in Hamburg, Germany. And I'm sitting here with Simon.
Awesome.
Hello, my name is Simon Zambrovski. And it's always good to be secondly introduced after Jan because we share the same city, the same country, the same company we work for, and actually we are doing very similar things. So I'm also IT consulting, doing backend development mostly in the Java and wonderful Axon world.
Awesome. And it's so wonderful to have you both back. And I'm really excited to talk about this topic that's actually a bit new to me. So I'm really excited to learn more about it and talk about it. So today we're talking about Axon Avro Serializer. Let's start by just jumping right into it, I guess. So what we have these three buzzwords: Axon, Avro, serialization, all of these really wonderful topics that we want to go through. So maybe let's start with serialization first of all. Why is it important? Why do we want to serialize things? Can you tell us a little bit about that?
Let me try to answer your question. So, in general speaking, in computer systems, serialization is kind of a process of conversion of data from in-memory to a serial stream. That's why the name serialization. And usually you do this if you want to write data on some storage. And the deserialization, very long word, and most computer programs try to correct them because it's kind of evil. And so it's an inverse, right? So take the serial stream and construct the in-memory representation back. And this is a very interesting subject if we speak about event sourcing, where all the data that we store is actually the serialized version of our events. And the events sourcing is usually introduce a concept of event store, so a place where all the events are stored. And in order to write the events to the event store, you need to serialize them, and in order to read them, you need to deserialize them. So this is how this this concept works, why it's relevant for Axon Framework, for event sourcing systems, and so on. And the interesting part about the Axon Framework is that it is a very interesting way how serializers are implemented. So there is a plugin mechanism to provide different implementation for serialization. And it's important to know that Axon Framework is a generic framework. It doesn't know the semantics of the events that it's storing, right?
Yeah.
And so it provides a way to say, I can decide how this deserialization takes place. On one hand, on the other hand, you can choose this decision is independent from your event store. So
absolutely.
After this process happens, you can decide where actually the physical storage takes place. So it can be a GPA event store or a Mongo event store, or if you have an Axon server, of course, you are using Axon server as the event store. So independent what store you're using, you need to serialize and deserialize stuff.
Yeah, and I know that in Axon Framework, we use the Xtreme serializer and Jackson serializer. So can you describe those a little bit into more detail?
And as a part of the framework, you have actually two serializers already provided, so you just have to activate or to choose one of them. There is a default, which is Xtreme, which will serialize all your events into an XML data, and then this will be written to some storage.
Right.
The advantage of this is that you can, Xtreme is very kind of easy
very
to
verbose.
use.
Yeah.
It is verbose, but the advantage is it can serialize almost arbitrary Java objects and Java structures.
Correct.
So there is almost no restrictions what it can do. It looks not very nice if you look on the serialized data, but it is very universal in the usage in the application. And this has some side effects. So it can happen that some artifacts from your Java ecosystem will end up written down in some strings inside of this XML. And of course, if you're doing something like refactoring, changing something, this can cause a problem, actually.
Right.
And the second one is, as you mentioned, it's Jackson. It's a well-known framework for serialization between especially Java and JSON. And it's an independent product, right? So it's an open source library, pretty large, pretty complex. You can do wonderful things with that.
Yeah, very popular.
And
right.
Very popular, actually, also. And JSON is, of course, much less verbose than XML.
Right.
But you have some limitations in a kind or in a way how Jackson is actually used mostly. So if you need to tweak up your serialization, it's usually a setup on your Jackson configuration. So that means that just saying, I'm using Jackson is saying something. You will know that, okay, there will be probably JSON coming out, but actually you don't know what kind of JSON will come out because you can configure it a lot. And so to tell you a joke, if we have some problems with serialization issues, we have a prepared JUnit test that you just copy it from one project to another. It's the same test, and it takes any kind of combination of different data types and just write it down to JSON and then convert it back to the Java object. And then you can tweak the options to say how I would like to represent local date or offset date time or whatever. And, and this is the same test for any kind of application. You can apply it in every project in order to make sure that it's really tuned up in a way you want.
Absolutely.
So if we speak about something like, persisting events forever, this configuration is becoming very important, right?
Yeah, absolutely.
Yeah, so
but I think at the same time with JSON, one of the downsides of JSON is that it's very repetitive, isn't it? So when you want to store a lot of data, it can take up a bunch of your CPU, right? So that could be one of the downsides of JSON. With all of that, so we have some really great benefits with both the Xtreme Serializer and also Jackson, but then you decided to use Avro. So Jan, why did you decide on using Avro? What was the sort of deciding point that you said, okay, neither XML, for example, or JSON is working out, so let's figure out a new way. And Avro, even though it's a new topic to me personally, it's been around for a really long time, right? So tell me a little bit about it.
Yeah. It has been, but I wasn't aware of. So you make it sound far more planned or motivated than it actually was.
Right.
There's this mythical article that I couldn't find when I prepared for this podcast. It was I don't know, 4 or 5 years ago when I started working with Axon. I read everything I could get my hands on, every documentation, all articles, and there was this one article about serialization that said the default is XML Xtreme. In production, you probably would want to use Jackson, but Avro would be better. Something like this.
Oh, okay.
We couldn't find it again. Simon said it may be in a webinar from Alat. We don't know. But this planted a seed in my head some years ago. And I said, if this is better, then why don't we use it? Yeah. I had some discussion. I had some discussions with Alat a while ago where he said he tried it and he didn't really like it. And so, but this year was not the year where we said, okay, let's just explore and give it a try. And I just started like you. I had no idea. I heard the word before, but the question for me was, what is Avro actually? So the first thing you might wonder is it's not an acronym. I checked this. I didn't find any good explanation. It's just a name. They use a logo from a old British plane factory. So there was a plane factory called. Maybe they want to fly. I don't know. But as you said, it's been around for a decade now. It's been invented by clever minds around this Hadoop ecosystem. So I believe the people know how to build really performant serialization frameworks. And basically, Avro is the serialization and deserialization format like JSON XML, but also it's, of course, a tool set and a framework, open source. And it's currently invented in the Hadoop space, but it's now a standalone open source project maintained
and
by
Hadoop,
Apache.
I was going to say it's now owned by, or maybe it was owned by Apache in the past too. I don't know, but it's currently part of the Apache software library. I guess it's a framework. Since you did mention Hadoop, can you give me a little bit more explanation of what it is and what it's for?
It's a framework for distributed processing. So it's a clustering framework with this nice elephant, right? So what they do is actually if you have something like problems that can be deduced to something like MapReduce, which you want to run in a huge cluster, when you say, okay, I can divide my problem into small parts, then distribute it over a large computational power, and then again combine the solution together, then you probably install something like a Hadoop cluster with 200 nodes or so. So they are doing large distribution computing platform.
Yeah. And what Simon was mentioning regarding the elephant, there's like the logo has an elephant on top. So it wasn't a metaphoric thing. It's like a literal elephant on top. It looks like Dumbo, but it's like a little elephant on top, which is what it is. So Simon, sorry, we interrupted your explanation. So going back to Avro. So yeah, let's continue. So this is
so I was sitting there and I knew nothing about Avro, so I checked. And what separates or distinguishes Avro from the basic XML and JSON formats Simon mentioned before is that Avro is a schema-based description language. So you have the schema-first approach. So instead of writing POJO data classes and using some serializer to get text, I define the structure of my event first. This is a JSON dialect I use to describe the schema. And this schema has a great benefit that to share the information, what this event looks like, I just have to share the schema with other systems or other teams, because I can use code generators to generate my POJO classes that I actually use with the Axon Framework to interact. What's also a really cool feature from the Axon Serialization is it supports JSON, so you can actually just have an Avro schema-based object and just write it down to JSON. Works fine, but then you lose most of the benefits. What makes it really interesting for event sourcing and event processing is that they have a binary representation. So they can really shrink it down. You use all this human readable, the claim of XML and JSON is human readable, but you can really store it down. And to be fair, if you look, for example, in the append-only data structure of the Axon server, there's nothing human readable anymore anyway. So it's just a byte array dump that you write out. So this is a really cool feature when you think of having this verbose XML compared to some small binary storage if you keep it millions of events for years from now. And another thing that is really important, speaking of storing events over multiple years, the schema in Avro have a compatibility matrix or behavior. So it's not, I try to deserialize some stored JSON string and I get a null pointer exception because a field is missing. I can analyze the structure of the schema and then decide what to do based on these facts, which at least we expect to be very beneficial for event storage and especially upcasting of events.
Right. So going back a little bit, Jan, we talked about these schemas and that it's fairly easy to create these schemas and go from there. Do we create these? Where do we create these schemas? Can you tell me a little bit about that?
Schema first means that we just create a schema up front. So it's certainly a developer task, just like you would write.
So is it just kind of like you would with a Java class, for instance?
Exactly, yeah. So normally when I work with it, I have my IDE and I have my editor and I start writing schema. There's tool support for the IDEs and everything. So this is just a schema. So and you can just read the schema into the Avro framework and start working with it. But since Axon will require Java classes to work, so I cannot write an add event handler on my projection and just expect some byte array. The routing won't work. So what we use is in our case now a Maven plugin, but there's also tools for Gradle. We use code generation. So we use this condensed JSON schema information and we get some Pojo class with builder and everything included. And we work with that from there on. Yeah.
Nice. Very good. So you did talk about sort of starting with Avro and so on. When and why should we use Avro and what is the benefit?
I think I mentioned a few topics already. So the one key feature is distribution. So this is what we discussed, Simon and some colleagues, all the time. There's no best solution so far. I have this one system that is keeping the aggregate and is responsible for the context and the events, and I have another system that also consumes events. So, and if I do the regular approach, which just writing a Pojo class and putting my add revision and add target identifier annotations on it, I have to share the whole class with this other app or team. And I have to version it. So this is now my 1.0.1 version of the event library for my bank account application. I don't have this because I just have one JSON file describing the layout of the event, and I share this. Of course, now the question is, how do I share it? Yeah, I can just send it you via email, but this is boring. So normally I would use some kind of registry, so some central component where I can read schema and then use it in my project.
Yeah, I think one additional thing to note is that if you're sharing a schema, or if you think of a schema, this is your primary artifact, right? So if you design a Java object that is being serialized, so what happens in the end is you write a Java class, then you have a serialization framework of your choice with configuration of your choice, and in the end you get a serialized image of bytes. Okay, so something. Then you can analyze this something, and on the other side, on the consuming side of this event, you need to match with your structure and with the, again, serialization or deserialization framework of your choice and configuration of it. So you need to match it in order to be able to read it. Okay. So in terms of a mental model, you're not communicating what you are actually sending over the wire or what is stored, but you are, you're kind of doing something in a Java world. Then it gets some representation, you can tweak and control it, and then you go back. Okay, so and there are no many choices what to do here, right? So in the end, you end up in a shared library, which you definitely don't want if we speak about loosely coupled systems and microservices, and you run it, you build it. So you don't want to communicate a shared library. Okay, so you want to communicate the idea of the structure, what is being serialized, and this is the advantage of this schema-first approach. So you go much more on the primary artifact and less on how it's implemented my current system.
That makes sense.
So I
yeah,
think
that makes a lot of sense.
That's the additional.
Yeah, the schema first approach that we like to use here absolutely makes sense. And Jan, you mentioned a registry. So what is a schema registry?
Yeah, should explain that. I think when I talked about the binary format, I missed a really important point. So you write the schema, you register to the Avro framework, and the Avro framework then can calculate a unique ID for the schema.
Gotcha.
So basically, it's a hash. So you
okay.
just take. So whenever you change something, this ID changes, and this binary format, single object encoded to use a real name, has an internal defined structure where this schema ID, this hash of fingerprint, is included. So my serialized data includes a pointer to a schema from which it derived. So this is why for working with this binary format, I need a registry, because at the moment I have this byte array and I want to read my bank account created event from it. I don't know what it is. So I extract this ID from the binary code, just reading some, I don't know, 8 bytes number. And then I need some central service where I can say, please give me the schema for this ID. And this is a schema registry, which, to be fair, is an additional component. But if you think of a namespace schema for XML, you also have resource locators in the header saying that this namespace can be read from some URL. So this is not really completely new or makes Avro less elegant or something. It's just a necessity in this case.
Absolutely.
So yeah, if you look on the market today, schema registry really is a simple application, right? I mean, I told you the schema is JSON and you have an ID to identify it. So it's the lookup is a basic get operation. You can just write it in I don't know, 2-3 lines of code. But managing the schema, keeping track of the compatibilities, keeping revisions and everything. We have tools for this. I think the most prominent today is the Confluent schema registry. So the Confluent Kafka ecosystem uses Avro a lot, and they have a schema registry for licensing reasons. We started working with the Apicurio. It's a product from Red Hat, which is also usable. But we plan to support more registries in the future.
Absolutely. And I think in one of the sort of preparatory talks that we had prior to our recording session today, you did mention that a registry, you can register your schemas and also query for these schemas. And that's, I think, an important point, because we are not just sort of pushing in the data, but we're also getting that data. We want to query that data. So this registry is basically the tool, I think, right, to help query for the data that you have. Am I understanding that correctly?
That's true. And what a bit the downside was when we worked on this is that the Avro serialization format itself is specified, so you can read how every byte should look and everything. But if you provide a registry and how you provide a registry is totally up to you. So there is no common JSR schema registry interface you just implement, and this is something that really keeps us working at the moment
Yeah.
because we have come up with some adaptor library. So we decided that all these different aspects do not belong in the Axon serialization extension. We have a separate library where we go on and one after the other will implement the proprietary API from different vendors.
So you currently are busy doing your Avro registry adapter, because this is something that is really independent of Axon Framework.
Exactly.
Yeah, gotcha. So, and you did mention that the registries that are supported, you mentioned that you're currently working with Epicurio, but you want to kind of have support of other registries as well, like Confluent and other libraries as well.
Just from how the registries are used on the market, I think Confluent would be really great to
beneficial to have. Yeah, absolutely.
Yeah, because I mean, if you use this Confluent stack and you already have a registry, it's really hard to say now you can use Avro Serialization with Axon, but not with the registry you already are running. So
right. So then that causes additional work for folks that are using it. And yeah, Simon, go ahead.
Yeah, in addition, I mean, there are also some other ecosystems, right? The Confluent is kind of, this Kafka ecosystem world that I just read several days ago. I was looking on Azure Event Hubs, which is kind of messaging inside of Azure Cloud directly. And for example, they also have a registry, so we can. And this is the idea, to separate this, actually the implementation of these adapters from the actual Axon Avro Serializer, and to make it pluggable there. To say, so if you come up with your registry of your choice, or I don't know, your ecosystem, then you can just plug it in and then still use it. I mean, it was important for us to define that there is something like a registry interface, so how we expect the registry to behave. And now we can build any number of implementation for that.
Yeah, that's really cool. It's really exciting. So I'm really looking forward to it. Now, how does the Avro Axon serializer work then?
Very good.
Yeah, let me jump in there.
I'm assuming because you created it, so it better work really well.
Yeah, as Jan already said, so you have this special format, which is this is single object encoded, so containing the schema ID for the lookups, and so in essence, it's a kind of a reference to the schema, and we use the schema registry to look it up. So that means, of course, that the schema needs to be present there, so you can go back to this enterprise-wide one installation of a schema registry where all the events schemas are, of course, provided. At least if you need this global scope, or you say, okay, my microservice scenario, I have several schemas, and my different contexts have places to look up what is stored where. So if we serialize an event, so we need this schema ID to be written inside of the data, right? Because we actually we have the payload as an in-memory representation, so we have a Java class, and now we say, now put it please inside of this byte array, and of course this information gets in. So if we we read the schema ID and then basically write it down to the payload, then the message is sent over. On the deserialization side, we make the inverse, so we look up this ID and use it, right? So the interesting part is, so Jan already mentioned that we actually separated this code base in two libraries. So we have the Avro specific library and the more Axon specific library.
Okay.
And on this Avro library, we actually provide decoders and encoders between different formats. So if we just for short forget about Axon serialization, so what we need to do is we have a Java class. But so you have a generated event, right? So you wrote down a schema, and this is an Axon event, okay? And this is a POJO finally, right? And you have this POJO in a hand, and then you want to say, okay, now write it down to a byte stream. So and what we did is we created a converter doing this, especially working with external registry you can provide.
Right.
And the deserialization is an inverse approach. So you have a byte stream, and then you say, okay, I would like to get the event out of it, which is again part of my application, a Java class. So using the schema registry. So the process of the serialization is pretty straightforward because we have a Java class, which is, the most verbose stuff that we can have. We have the reference to the schema there. Anything is connected.
Right.
So we just write it down using this converter to a byte stream, and then the framework takes over and stores it. The deserialization is a little bit more tricky because what we have at place is a byte array written by some other application, but this byte array in some place contains this information to the schema ID, right?
Yeah.
So what we do is we look up the schema ID, and what we get back from the registry, hopefully, is a schema, but it's a writer schema, right? It's not the reader schema. So that's the schema of the guy who wrote down this event. So the next step is that we need to determine what is the matching reader schema for that.
Okay.
And we assume, as Jan said in the beginning, there is this process of generation, right? So there is some logic how, starting from a namespace and a name of the schema, you get a Java class. So we try to find a matching Java class for this schema. And if we get that, so if it is in your class path, hopefully, because you need to have it actually in order to read the event,
right?
Then what's come in is now we have the writer schema. This is the one the byte array was written with, and now we have the reader schema. This is what we want to try to read it with, right?
Which has to target the writer. Yeah.
Yeah, exactly. So now the power of Avro is to say, look, now before we just trying to do this, we can compare the schemas and check if they're compatible actually. So maybe we on the reader side have an older version of this schema, and this is actually not possible to read it, for example, right? So, but we can. I mean, there is a chance to do so. It's we will speak maybe a little bit later in this if we speak about upcasters.
Yeah.
Because
which I'm planning on.
That's the first place. Yeah, but that's the first time you have the chance actually to do so, right?
Yeah.
Because having XML, you can try to deserialize, and if it works, it worked, and if not, you have an exception, right? So there is no pre-check or something.
Absolutely.
Yeah. So for the serializer itself, I mean, as we said already in the beginning, the serializer is actually an interface provided by the Axon Framework in order to enable this pluggable mechanism. And so internally, additional to the serializer, there are also Axon converter, type converter, which are responsible for generic conversion of data, actually. So something like make me a byte array out of string, or make me an XML node out of string, and so on. So this is usually used together. But in the end, if the framework says, okay, I would like to get the type T from you as an object in Java, then that's the responsibility of serializer to do so. And so we are using our byte to single object encoder and single object to byte decoder. No, another way around. Actually to implement the serializer. And this serializing the serialization of events is not only the payload, but we also have something which is called metadata, which also needs to be serialized, deserialized. And of course, we were also working on that. And yeah, an interesting thing that we observed that actually, because Axon provided these two implementations, there is, as Jan said, there is the payload and there is an envelope, and there are some types in Axon Framework involved in the serialization process. Especially, you have something which is called serialized object and serialized type, which is all required because there are frameworks like Xtreme and Jackson actually out there. And we noticed that since Avro contains this information inside of binary data, so the schema information is part of the binary data, we actually don't really need this, these envelope objects. So we are passing them around because the frameworks want us to do so.
Yeah.
But essentially, the information can be solely retrieved from the schema information inside of it.
And that's because,
so that's
and for that, it actually saves a lot of space, right? It's one of the things that is beneficial about it too, right? Because the schema itself is really not contained in a serialized format and so forth.
Yeah, so this is so in order to use it, if you are just a user of the serializer, you don't it doesn't matter actually how it works internally. So what you do is just activate that, and then it just starts working. In order to work, as we said previously, you require to configure the registry. So then it needs to know where to look up schemas and so how to read and to write data.
Yeah.
And of course, you also need some way how these schemas get registered there in this registry, right? So they need initially to get there, and there are different ways to do so. So we worked on some of them, like you can do the registration on startup of your application, or you have some integration in your CI/CD pipeline. So basically, if you're generating your classes, you can also say, I'm also registering the schemas in the registry, or you can do it manually or whatever. But they need somehow to get there, and that's not part of the serialization, of course. They just need to be present.
Yeah. So as far as deployment is just, you can do whatever you want with them.
Yeah, exactly.
Gotcha. So now this brings me to, I think, Jan's favorite topic, which is upcasting. So
exactly, yeah.
Simon mentioned it too. We're highly anticipating this upcasting.
Yeah, of course, this is a reoccurring topic because nothing to do with Avro. It's just the way what we're talking about. We have an append-only store. We keep everything for years. And the best rule about upcasting is just don't do it. Yeah. So cool events never change. If my bank account created from 5 years ago just stays the way it is, and I never, repackage my application, anything, it just works. But we have to be prepared for the case where we just missed the critical field, and it's just
I have to version it basically, right?
Yeah, then you have this. The Axon term is revision. So I try to stick to the word revision, but basically it's versioning. Yeah. So you say I had this version 1 some years ago, and now we added a custom ID or initial balance to the event, whatever, and we cannot work around it. So you have a Java Pojo class today, and the deserializer tries to match this byte array, which in case of the default serializers is human readable JSON or XML string. Try to match it to the class you have today. So the past enters today. And if this doesn't match because you have a missing non-nullable field or anything, this is where you start considering upcasting. So you have in the Axon Framework a mechanism to just register. It's a mapping, right? You have a stream of events, and you register a mapper that takes an input, modifies it, and gives an output. And you can say this upcaster mapping is responsible for revision 1 to revision 2 for my bank account created. And basically, what you do is you cannot use your Pojo, because you can only have one version of the class on your class path.
Right.
So you will work with intermediate formats. This is JSON node for the Jackson world, and document. It's some W3C document stuff. And what you basically do is you have to know the difference. So you have to understand what the problem is, and then you in this intermediate format, you just add nodes. So yeah, you just say, give me this intermediate representation, and I just add a field, which is called, I don't know, customer ID, and I add a value, and then I'm compliant to revision 2. This is, and basically, yes, as I said, it's inevitable, so you have to do it. Yeah. Sometimes you should try to not do it all the time. So probably it's best to just publish a customer ID edit event afterwards. Or I discussed with Simon today that he read an article where some really strict engineer proposed to just use brute force to copy the whole event store to a new event store where you get this fix once instead of doing upcasting all the time.
I see.
But yeah, this is upcasting, and I see your face. You now probably wonder, as we propagated the benefits of the binary format, this highly condensed format. I can guess your question is, will this still work, and how does it work?
Right.
Yeah. This is something we thankfully discussed before. Otherwise, we would really have a problem. But turns out it not only works. We really see benefits in it. So just short to. In the Avro world, clever guys and girls invented it. So they have an intermediate representation as well. So we talked the whole time. We talked about generating a Java class from a schema definition. This is a specific record. So the class generated extends from specific records. So this is something you really know. You have the schema, you have the type. This is linked. Perfect. But there is also a generic data record, which is basically for the Avro world as a string object map would be for the JSON world. So you can just address attributes of your event via this intermediate generic representation. So when we do so, we prove that Avro does not fail when it comes to upcasting, but we don't really gain anything. Yeah, it's still me knowing the difference between revision 1 and revision 2 and manually adding a field. And this is something, but of course it's still required if you have, I don't know, dynamic changes. So you have to look up something in a service call and then add the custom ID to the. Of course, this is something that you probably won't do in upcasting millions event per day, looking up a REST API to fill the field. But the Avro schema, we talked about it just shortly in the beginning. They have the concept of schema evolution. So they don't really think of revisions as we do in the Axon event world. They think of, I have this schema and I have this schema, and I can compare how compatible are they. In case it's the same with JSON, in case I just added a new field and said it might be null, nothing happens. It will just be null. But the great benefit is that for fields that are required to be non-null, I actually can define in my new next evolution step of my schema, I can say this has a default value.
Gotcha.
For example, I don't know, not available, or and this is for just, of course, this you don't get information. This is just static information or static data, but this could work automatically. Yeah, you don't need an upcaster because Avro does it doing the serialization and deserialization that Simon mentioned. So you have writer schema, reader schema. You see, okay, I would be compatible, but this field is missing. But yeah, the new schema has an information. Use this default element, and you're fine. So you don't have to care about static updates. And so this is what we already have implemented. There's a working integration test for it. And then there's this other concept Simon also mentioned. You have writer schema your reader schema. So the reader schema would be the class that you have on your class path and need to somehow build.
Right.
And instead of just trying out if it fails or doesn't fail, try catch IO exception or anything, you can say, Avro, please tell me how compatible are those schema definitions.
Okay.
And then you get basically like a constraint violation list. So the machine tells you what is wrong.
Okay.
And not implemented so far, but our hope is that we can leverage this to have some dynamic generic upcaster that just interprets the incompatibilities you get from Avro. And then you, instead of registering revision 1 to revision 2 and revision 2 to revision 3 at this field, you just say, in case the incompatibility is missing account ID. For this case, I have a handler that knows how to deal with missing account ID. So this is speaking of today, science fiction, but hopefully close.
Fancy stuff.
Yeah.
Cool.
And then it would turn out at least that this is really, besides data storage and schema definition, this could really be a great benefit of using Avro. Because, to some extent at least, you can get rid of this manual add element upcaster and keep it on a more abstract, in case this is wrong, then please do level.
Do X, Y, and Z. Yeah, that's really cool. That's really cool. So is it available to use right now, this Avro Axon serializer?
Of course, I thought you just wanted to name me on this upcasting, generic dynamic upcasting. No, of course, yes. We have a strict Simon. I have a strict policy: first build, then talk. So
good.
Before we came to you and said we have something exciting, we actually built those two libraries, and they are available on GitHub. I think we have a link in the show note or something like this. Yeah.
Gotcha.
And we also were brave enough to do a Maven Central release. So you can just use it and start exploring.
And I think you're planning on writing some articles about this as well, right? Or have you already?
No, that was the initial plan, to say, okay, how many articles do we need to write actually? And then we started the discussion to structure all this, and then we came out like, let's do the podcast first. This will kind of clarify some stuff, and then having answered that and having the structure, now we can go for it and go deeper, and of course provide some code samples because sometimes it's easier. Yeah, and in addition, we are, especially for the serializer, we already created kind of a documentation page that explores some of these core concepts: that what is a registry, why we need this, why we need that, what is how's the developer flow actually, that you start with a schema, generate classes, then.
Yeah. Fantastic. And then I'll take that information from you guys, and then I can just publish it when this episode goes out. That way people can take a look at the documentation.
Let me maybe just add one thing, because we forget to talk about it. We have actually, Simon started implementing it. We have this eat your own dog food or do a full recursive cycle idea. So we said, okay, the registry component actually is quite simple.
Right.
Why do we need an additional registry when we already have the Axon framework and the Axon server? So what Simon started building, what we were discussing today, we want to use Axon server event storage as the primary schema registry.
Nice.
And then hopefully, also science fiction, provide an Axon server plugin that does this. So you can use your existing high availability end node Axon server landscape to have this aspect as well.
I really wanted to ask you that, but I didn't want to put you on the spot or like throw a new project as to, hey, are you going to do a plugin for Axon Server without you being prepared? But I'm so glad you are doing it.
Basically, funny story. Also like to mention. I said that, of course, with this binary format, you lose this human readability aspect, which was really, really, really funny because, or not funny, it was disappointing. When we started using the Axon Avro Serializer, and you use the Axon server dashboard, and you want to explore the events that are stored in the Axon server, you don't get nice readable payload. You cannot search the payload as anything. It's just some UTF-8 byte. So the machine thinks it might be a string, but actually it's just garbage. And for this, we actually, with support from Mark and Alad, we built a plugin that links into the event stream sent from the server to the dashboard. And we use the deserialization, but not, of course, to a concrete class specific record, because the Axon server doesn't know about my bank account created dot class. But we use the intermediate format and then just write to JSON. So you can actually use the tool today, not science fiction. And if you look at it from the server dashboard, you won't recognize that the internal storage is not even JSON, because we intercept and transform. This is really,
That's really neat. I didn't know about this.
So, in order to use it, exactly. So there are two plugins actually. So we wrote the deserializer itself, which does this job. But again, as we mentioned, we always need a connection to the registry. So there is also a registry connector, which says, okay, so currently you say, okay, I have, for example, Apikuri installed somewhere. I need to configure Apikuri in my application as the registry. And of course, if I want to look for events and read them in the Axon server dashboard, I also install a small adapter there, which is actually the server plugin for the Axon server, and then is connected to the same registry, and then you can read them.
Okay.
So that's the idea. And what Jan was speaking about is that the registry itself could get at one day as part of the plugin. So you don't need an external registry if you have an Axon server. And this would be even less infrastructure components. For
exactly. Makes life easier. Fantastic.
So to answer your question, what's next? A lot. we are hooked, and we plan on doing more. And we would greatly. We would be happy. So let me put it this way: if you now listen to this at home and you are curious and you try it out, please contact us. We are really excited to explore real world use cases and get this out of the laboratory.
Yeah, it's like the sky is your limit, because there's so much you can do with this, which is really, really awesome, you guys.
And of course, we're also planning to now. Now it's public. Now we already started this discussion with Stephen and Allard to get kind of official extension status. So we plan to do so because it's much more prominent on the Exonic side.
Yeah, nice. Really, really exciting stuff. Thank you for all of your really amazing work. It's really exciting to see that there's so much you can do, and so many possibilities, and I'm really excited to go and play around with it, which is really neat. Awesome. Share all of the information with me. I will go ahead and link the documentation and also the repositories if you'd like to share that, and that way folks can go and check it out and give you feedback, and hopefully I'm sure there will be a lot of positive feedback, but also any other suggestions that may have, then you can use on your roadmap which is really cool. I know you probably have a long scroll of things that you want to implement and work on, which is exciting. I know you guys are always busy and coming up with really nice ideas. So I really appreciate you sharing this with me today. And I feel so special that you decided to do it on a podcast before the articles went out, which is really awesome. So thank you. Really a pleasure to talk to you both.
Yeah, pleasure to me as well.
Thank you, Sarah.
Thank you. I hope you have a fantastic rest of the day, and talk to you soon, hopefully.
We will certainly
Thank you. Thank you for having us.
Of course. Bye-bye. Pleasure. Bye. Thank you so much for listening to my talk with Jan and Simon. Please join me next time as I discover other fantastic topics. Until then, have a great time and happy coding.